Hi guys, some of us were saying that we were struggling a wee bit with the lesson 4 material, so I thought I would make a quick video, although I don't think it will be that quick, with each of the questions being answered by me. So if there's only a couple that you're struggling with, feel free to skip on to those questions. If you feel like you had no idea how to answer any of these questions at all, you can work through this video with me as we go, okay? So question number 1, the hot water tank consists of a hemisphere on top of a cylinder. So the first thing I'm going to do is label them. So H for hemisphere and C for cylinder. We are told that the diameter of both the cylinder and the hemisphere is 75. So that's our diameter here. What we might want to know though is what our radius of the two things are. So because the diameter is 75, the radius is half of that. So that's going to be 37.5 centimetres for our radius. We are told that the cylinder is 60 centimetres tall and we need to calculate the total volume. The minute you see a volume question, and specifically questions like this where it's really wordy, it is so important that you read the full question. I know in maths we don't really like words, we prefer numbers, so we sometimes skip to the bits that we think we need. But it's really important there because it is telling us that both the cylinder and the hemisphere have a diameter of 75. I'm going to start with my hemisphere. So volume of your hemisphere then is going to be our 4/3 pi r cubed, and then we need to divide that by 2 because it's half of our sphere. So we're doing 4/3 pi times by 37.5 cubed and then dividing that by 2. So the first thing I would do is my 37.5 cubed in my calculator. So 4/3 pi, and then that's becoming 52,734.375, and then we are dividing that by 2. So what I would do in my calculator then is do my 4 times by pi times by that number. So if you've still got your big long number there in your calculator, you don't need to clear it. Just straight away hit multiply by 4, multiply by pi, and then that's given me 662,000, so on. So we've got 662,679.7, but we still have to find a third and then half it at the end. So we're going to divide by 3, divide by 2. I've ran out of space, so I'm just going to go along to the side. Again, I don't need to clear my calculator if I've still got my big long number, the 662,000. Just keep that and hit divide by 3 equals divide by 2 equals, and I get 110,446.6 centimetres cubed. Now that we have done our hemisphere, we are going to move on to our cylinder. So volume of a cylinder is equal to pi r squared h. So pi is just pi. We are timesing by our radius squared, so that's 37.5 squared, and then timesing by the height of our cylinder, which is this bit here, the 60. Now, when we are putting this into our calculator, just like last time, I'm going to do my 37.5 squared first because I don't want my calculator doing pi times 37.5 and then squaring it. So that is going to be pi times by 1406.25, 0.25, and then times by 60. That means that I get 260,071.9 centimetres cubed. Our final answer then is that we have to find the total volume. So total is usually a hint that we are adding. So total volume then is going to be the volume of our hemisphere plus the volume of the cylinder. And so if I add them both in my calculator, we get 375,518.5 centimetres cubed when I've rounded to one decimal place. Now remember, If you are using your 3.14 instead of pi, your answer will be ever so slightly smaller than mine. So if you are well out, then have a look and see where we've gone wrong. But if you're only slightly smaller and you've used 3.14, that is why. Okay, time for question 2. So this shape is to be erected outside an ice cream shop in Largs. It consists of a hemisphere on top of a cone. We need to work out the total volume. So again, we've got the hemisphere at the top and the cone at the bottom. So, so let's just start with the volume of the hemisphere. So we need our 4/3 pi r cubed, and then because it's a hemisphere, we are dividing it by 2. This time our diameter we've been given is 36. You can see here, I don't want to write on the shape because my red pen won't show up as well. So if it's 36, our radius is half of that, so it's 18 centimetres. So we've got 4/3 times by pi times by 18 cubed, and then dividing it all by 2. Again, I'm going to do my 18 cubed first. So we've got our 4/3 pi times by 5832, dividing by 2. So that's going to give us 73,287.1 centimetres cubed. But we still have to divide it by 3 and then divide it by 2 after that. So I've not hit clear in my calculator. I'm keeping the 73,000 answer and then dividing by 3, hit equals, divide by 2, hit equals. And that is going to give us 12,214.5 centimetres cubed. The next thing we want to do then is the volume of our cylinder. So that one is 1/3 pi r squared h. So it's 1/3 of our cylinder formula. So really what I'm doing is 1/3 times by pi times by our 18 squared, and then the height of our cone here is 50. So my 18 squared is 324. I've run out of space here, so I'm just going to pop over to the side with my arrow. So if I do my 324 times by my pi times by 50, I'm getting 50,893.8, but I still have the third, so I'm going to divide by 3. That gives me 16,964.6 centimetres cubed. And then again, my final answer I'll write up here. So the total volume is our hemisphere plus the cone So that is 29,179.1 centimetres cubed. When we are doing volume questions, it is really important that we have our units, especially in our final answer. I would hate for you to do all this hard work and then not get your final mark. This time what we have got is a cuboid and a pyramid. So I'm going to start with my volume of the cuboid because I don't know about you, but I find that my easiest formula to work with. We are just doing L times B times H. And when we are talking about the length and breadth, it doesn't really matter what way round it's going. So don't worry if you've done it the opposite way to me. What's important here is that we are multiplying these three terms together. So 0.6, 0.8 and 1.8. When I pop that into my calculator, I get 0.864 metres cubed. So let's be careful this time, our units are all in metres. My volume of a pyramid then is a wee bit similar to what we would do with our prism. So it's a third, but this time it is the area of the base. So I'm going to say AB for area of the base, and then times by the height of your pyramid. Because our pyramid is joined onto this cuboid so perfectly, we should know that it is a rectangle at the bottom. So my rectangle is just length times breadth. So 0.6 times by 0.8, but I still have my height to multiply by as well. If I pop that into my calculator, then I'm going to do 0.6 times 0.8 times 0.5 to give me 0.24, but that's just my multiplying. I still have to deal with my third, so we are dividing by 3, and that gives us 0.08 metres cubed. To get the total volume then, we need to add our two volumes together. And so that is going to give me 0.944. Be careful there when adding the decimals. And that's still metres cubed. It's a pair of identical gate posts. So I'm going to do my 0.944 times by 2, and that's for the pair. And that should give us 1.888 metres cubed as the volume needed for the pair of identical gate posts. For question number 4, this metal block has 4 identical cylindrical holes drilled out as shown. So the 4 cylinders that we can see here have been taken out this time. The diameter of each circle is 8. So instantly I'm thinking, well, if the diameter is 8, our radius is half of that. So it's 4 centimetres. First thing we've been asked to do is calculate the volume of one of the holes. So that just means the volume of one cylinder. So for part A, volume of a cylinder is going to be equal to pi r squared h. So that's pi times by 4 squared. And then the height of our cylinders, because they've been drilled right through our cuboid there, it's the height of 10. Apologies if that's a wee bit difficult to see, but it should be 10. Oh, we don't need the centimetres. That means then that we are doing pi times by 16 times by 10. So if we pop that into our calculator, we should be getting about 502.7 centimetres cubed. It's still a volume, so it's still centimetres cubed. And that's all we have to do for that one. That is the volume of one cylindrical hole. Part B, we need to calculate the volume of the metal block remaining after the holes have all been drilled out. So the first thing that I'm thinking is I want to know the volume of our full cuboid. So you can see here I did CY for cylinder, I'm going to do CU for cuboid. So for part B, volume of our cuboid is just length times breadth times height. So I need 40, 40 and the 10 again. 4 and 4 is 16, and I've got 3 zeros there, so it is 16,000 centimetres cubed. We know that we have got 4 cylinders, so what I need to do is find the total area that we are removing. So we need to remove our 502.7 multiplied by 4. So that leaves us with 2010.8 centimetres cubed. So what we need to do is do our 16,000, take away 2010.8, and that gives us 13,989.2 centimetres cubed for our volume. For question 5 then, we've said that a pump is used to blow up inflatable beds or paddling pools, and we can see here that we have to calculate the volume of air it can hold when the piston is pulled back. So we need to know that this bit here is the piston. We don't really care what volume that is because that doesn't hold any of the air, that's just a solid bit of plastic or metal. What we do care about is our cylinder and our cone. So if we start with the volume of our cylinder, we have got pi times by the radius squared times by the height. Now we have been told that this full length here is 12 centimetres. That is going from one edge of the circle straight to the other, so that is our diameter. Our radius then, we should know by now, is half of that, so it is 6. So pi times by 6 squared times by the height of the cylinder, so that is going from here to here, so is just 35 centimetres. Pi then times by 36, which is 6 squared, and times by 35 at the end. And that gives us 3,958.4 centimetres cubed. Now it's time for the volume of the cone, which is 1/3 pi r squared h. The cone is 1/3 of our cylinder formula. Can't do anything with the third yet, leave pi as it is. R squared is the same radius because that's still the same circle at the end there. So we're still doing 6 squared, and this time the height of our cone is going from there to there, so it is times by 15. That means we're doing 1/3 pi times by 36 times by 15. So what I would do this time is my pi times by 36 times by 15, which gives us 1696.5, and we are going to divide that by 3 as our third, and that is going to give us 565.5 centimetres cubed for our answer. We want the total volume when the piston is pulled back, so that means that air fills up that entire red section of our diagram. So again, my total volume is just going to be the volume of our cylinder plus the volume of our cone, so 4,523.9 centimetres cubed as our final answer for question 5. For question 6, we have got a metal block that's had a hole drilled through it and a blade attached, but we've just been asked to calculate the volume of the original metal block. So we're not fussed about the hole that's been drilled through it. We've not been given any information about that. What we should be able to spot though is that if we draw a line round here, we can separate it into a cuboid and into a prism, which is two shapes that we do know. What we can then do is start with the volume of our cuboid, so that is length times breadth times height. So I would use this as my length, this is my breadth, and then the height of the cuboid is just this section here, so that is my 6 millimeters. So I'm doing my 25 times by 15 times by 6, and that should give us 2250 millimeters cubed. The volume of our prism then is the same as the area of the face multiplied by the height, which is really like how long the face goes through. So in this case, this triangle here is the area of my face, and then my height is this bit here, so how far through our triangle is going to travel. My area of a triangle then is a half base times height, and then we're going to multiply that by the 15 for how many triangles we've got going through it. The base of my triangle then is going to be this section here, which is my 25. And then my height of the triangle is this straight bit here. We know that this full section here is 10, and we had already used up 6 for this bit here, because that will be the same all the way around that cuboid. So 10 subtract the 6 leaves us with 4. So we are multiplying by 4. So that bit there matches with that bit there. So I still have the times by 15 at the end. 25 times by 4 is 100, so half of 100 is 50, and we are multiplying that by 15. 50 times by 15 gives me 750 millimeters cubed. Last thing to do then is our total volume, which is going to be our 2250 plus the 750 to give us 3000 millimeters cubed for the original metal block. For question 7, we have been asked to calculate the concrete required into this step with the sloping ramp. The first thing that I'm going to highlight here is the fact that it is asking for in meters cubed. So what I'm going to do is change all of my numbers into meters. So that's going to be 0.2 meters, 0.5 meters, that's still 1.2, I'm just going to make that point clearer, 0.8 meters, 0.6 meters, and then that's maybe a wee bit difficult to see, but that is 1.5 meters up the top there. Now, we definitely know the shapes 1 and 2 that I've labelled, but our shape in the middle there is very similar to what we had last time. We don't know the volume formula for that type of shape, but what we can do is do the same as we did in question 6 and change it into a cuboid and a prism again. So I'm going to call this one number 3 and this one number 4. I'm going to start off just in the order that I've numbered them. So volume of shape number 1 is length times breadth times height. My length then is that 0.5. My breadth, now I've not been given a breadth here, but I need to know my sort of properties of my shapes. So this line here is the same as this line here, which is the same as this line here, which is the same as this line here, and finally matches with that line there because they are cuboids. We should know that those lines are all the same. So that means that this bit here is also 1.5 meters. So we're going to do it times 1.5 and then lastly times by 0.2 for the height of cuboid number 1. So 0.5 times 1.5 times 0.2 is going to give us 0.15 meters cubed. Volume number 2 is also length times breadth times height. So that is going to be 0.8 times 0.6 times 1.5. So 0.8 times 0.6 times 1.5, that is going to give me 0.72 meters cubed. And then volume number 3, well, my length times breadth times height is going to be 1.2 for that length there. My breadth is also going to be my 1.5. I've put my height and my breadth round the wrong way in that sum, but it will give us the same answer anyway, so it doesn't matter too much. But my breadth is 1.5, and then my height is this bit, which matches this bit, so my height for this last one is 0.2 as well. So 1.2 times 1.5 times 0.2 is going to give us 0.36 meters cubed. Finally then, the volume of our fourth shape, well, that is the area of the face multiplied by the height of the prism. So our face here is that triangle, so it's a half times by base times by height. And then the height of my prism is really like the length that the triangle is running all the way through it. So for us here, it's going to be that 1.5 again. I'm running out of space, so I'll have to do a wee zigzag pattern as we go along. The volume then is going to be a half times by the base of my triangle, which is 1.2. And then the height of my triangle, well, if we know that this full bit here is 0.6, that full bit there is 0.6, we already know that our height of our cuboid was 0.2, so what's left over is 0.4. And then we are still multiplying that by 1.5. 1.2 times by 0.4 gives us 0.48, and if I half that by dividing by 2, that is 0.24 multiplied by 1.5. And then that is going to be, we get 0.36 meters cubed again. Again, guys, I'm trying to squeeze this all into the one bit. So my total volume then is going to be my 4 numbers added together. We'll squeeze that 6 in there. So if I add them up, 0.15 plus 0.72 plus 0.36, 0.36, and that gives us 1.59 metres cubed as our total volume. Finally, we've got question number 8, and we are told that our storage tank consists of a cylindrical middle and 2 hemispheres. But if we've got 2 hemispheres, that's actually going to make one whole sphere. So this time what we can do is just the volume of our cylinder and the volume of our full sphere. I'm going to start with the volume of my sphere, which is 4/3 pi r cubed. That means we've got 4/3 times by pi, and then we've been told that our diameter is 70 because it is running that full way through. So our radius is going to be half of that, so it is 35 centimetres. And we need to cube that. So really what we are doing is our 35 cubed is going to give us 4/3 times by pi times by 42875. So I'm going to keep that big number in my calculator, not clear it, just hit times by 4 times by pi. So that is giving me 538.783.1, and we're going to divide that still by 3 because it's our third. So I'm going to divide by 3, and that gives me 179,594.38. It is centimetres, so it's centimetres cubed. The volume of our cylinder then is our pi r squared times by the height. Our radius of the cylinder is going to be exactly the same as the radius of our hemisphere or the full sphere there because they are joined together. So I'm still doing 35 squared, and then the height of my cylinder is just this section here. We know that our radius of our hemispheres is 35. So really I'm saying I've got 35 here and I've got 35 here. So if I take off the 70, which is those two 35s, I know that this section in the middle then is going to be 110 centimetres. So the height of my cylinder is 110. 35 squared is going to give me 1,225. And then I can just plug that into my calculator, and that gives me 423,329.6 centimetres cubed. We've been told that it is currently holding 250 litres already. What we need to do is work out the total that we can hold so far. So our total volume is just if we add those two things together. So our total volume here is 602,923.9 centimetres cubed. 8 centimetres cubed. And we need to know how many litres are in our centimetres cubed. So we need to be able to convert that. What we should know is that 1 centimetre cubed is the same as 1 millilitre of liquids. So 1 millilitre, sorry, 1,000 millilitres are in a litre. So 1,000 centimetres cubed is going to make 1 litre. If we divide our total by 1,000 then, we are looking at roughly 603 litres when full. So if I need to know how many litres it will take to fill, we need to subtract our 250 litres. So that's going to be 353 litres are needed as our final answer there. I know that this was quite a long one. Well done for sticking with me if you have made it this far, and I hope that some of these answers really helped us. Again, some of your answers might be slightly out, and that is totally fine. It will just depend on whether you've used pi, the pi button, if you've rounded in the middle, if you waited until the end to round. Don't worry too much, so long as your answers are roughly the same as mine or the answers that I've posted on the Teams.